Here we have a type called user with two required properties, name and age, and then we're creating a new user object of this type and then just printing the values here. Let's say that we have a case where we have this data partially or we don't have this data at all. This will not work because both of the fields are required in our type. To fix this, we can create a new type called partial user where we have both of these fields as optional, and then we use this type for our object. And now it will work with empty object, also it will work with the partial data. But we have a problem here that whenever we add some new field to our type user, let's say we add gender, we will still not be able to use it in our object because it is not a part of our partial user type. So we'll have to copy it from here and paste it here as optional. So we'll be maintaining our user type in two places. To fix this, TypeScript has a better way to do this. So we can type the same thing as type partial user is partial of type user, which is telling TypeScript that this partial user type can have partially filled user object. So if we remove one of these fields or if we make this object empty, it will still work in both the cases. As you can see here, we don't have age and gender in our user object and it is not throwing any errors because both of the fields are optional in our type. With the help of required, we can make all our optional fields to be required. So now if I put required here on our user type, it would make age and gender to be required also, and it will throw the error that age and gender are required. And now if I put the age here and gender here, the error will go away. So here we have an item. Let's say that we want a preview for it where we will have only the name and the image of the item. To do that, we will create a new type called item preview and pick from our item type only the name and the image. And now we can create a preview for our item with the help of this type. Now I will create a variable called item preview, which will use item preview as a type. And now we'll put the name here, item.name, and image as item.image. And then if I log it, item preview, it will log that and there are no errors. And now if we try to put description here, we can't put that because it is not a part of our item preview type because it is only picking up name and image from here and discarding all the other fields. And now if I remove it, the error will go away. Here we have a type item with a bunch of required fields, and then we're creating a new item object from this type with price, currency, name and description. Let's say that we want an item where we don't have price and currency. Instead of creating a new type from the scratch, we can just use TypeScript omit. So we'll do type priceless item is omit item, and then we just omit price from here, and then we use this type for our object, and now it will give the error that the price is not there. Now if I remove it, the error will go away. We can omit more fields also with the help of pipe operator. I'll put currency here now, and the currency has gone away also. So here we are declaring an object with the help of const, and then we're printing the values here, and then you can see the output in the console. If we try to update the value for our object, let's say we make it an empty object or something else, it will not allow us to do that because user is declared as a constant. But if we try to update one of the fields inside of our object, like name to be, let's say, Jane Doe, JavaScript will not complain and simply update the value because this is how just the constants work in JavaScript. They stop you from updating the value of the variables, but they can't stop you from updating the nested fields. Same goes for the arrays. With the help of TypeScript's asConst, we can make our variables to be fully immutable. So now both of our fields have been made read-only, and if you try to assign the name a new value, it will throw the error that name cannot be updated. It works on the nested objects also, so if I put here education, degree is SE, and if I try to update that here, it will not allow us to do that because degree is also immutable. It works on all the nesting levels, so even if I have a variable at 5th level in this object, it will still be made immutable. The same applies to arrays and other types also. So here we have an array of skills and we are pushing a new skill to it and everything seems to be working fine. To make it immutable, we will simply put asConst here, and now TypeScript will complain because we are trying to push to a read-only array. And now if we remove this mutation from here, the error goes away and everything goes back to normal. As you may have seen in the last example and this example, we are using asConst on the values. For the types, we have a different way of specifying the immutability. Going back to our last example, now we have a type user. Our user object is now using this type. Then we are updating some of the values here and then just logging the user here. Let's say that we want to make the name to be immutable. To do that, we'll just put read only here, and then now it will start throwing error that the name cannot be changed because it is read only, but the age is still working fine. And if I put read only in front of the age also, and now the age is also throwing the error. But what about object? If I put read only in front of the education and I try to update the education, it is throwing the error as expected that the education cannot be changed. But if I try to update it with user.education.degree is IT, it is not throwing any errors because read only updates only the first level. For any nested fields, you still need to put read only in front of them. And now it is throwing the error here also. Now let's see how we can make our arrays to be immutable. I've added skills as an array of strings in my user type, then I have assigned some default values to the skills, and here I'm trying to reassign value and then trying to push to the same skills array. Now if you put read only in front of the skills array, you will see here that the reassignment is throwing the error, but the push is still working fine, because just like objects, the key cannot be reassigned a new value with this read only, but the strings array can still be pushed to. To make this also read only, we'll have to put read only here. And now the push is also throwing the error. There's a different syntax for this also, so I'll copy it and I'll paste it, and then I'll make it read only array, and then I'll remove this, and now it is giving the same exact output. Here we have a type user with two required properties, name and age, and then we have an optional string called profession. And then we're creating a new user object of this type with all the values inside that, and then we are printing the user object to the console here. Let's say that we want to get the name out of the user object into a separate variable and print that. So I will do const output of type string with the value user.name and print the output to the console. And as you can see that our name is printed here. But now let's say that we want to get the profession into this output variable. So I will do user.profession, and you will see that on our output variable we are getting the error that type string or undefined is not assignable to type string. And the reason for that is because profession is a optional field, so it can either be string or it can be undefined, but our output variable is of type string, so it always expects the value to be the string. One way to fix this is that we either put user.profession as string here, so this way we are telling the TypeScript that ignore the type of user.profession and always consider it as a type string. A better way to do this is to use the non-null assertion operator. So we can just put not at the end of the profession, and you will see that our error is gone. So this is the non-null assertion operator, which tells the TypeScript compiler that keep the type of whatever the user.profession variable is and remove the null or undefined checks from that. So this is equivalent to saying that profession is a required property in the user type. And now if we run this, you will see that our error is gone and our profession is being printed to the console. We have a user object here with the name set to John Doe and age set to 27, and we don't have the type assigned to this variable. But if I hover over the user variable, you will be able to see that TypeScript was able to infer the type of object and assign it the name of string and age of number. Let's say that we want to create a new user object. So if I put const user2, and if I try to get the auto completion here, you will see that we are not getting the name and age here because this user2 has nothing to do with this user. And we don't have the type assigned to it, so we are not getting the auto completion. Let's say that we want to get the type of this user object in a separate type so that we can reuse it in the future. So for that I can do type user is type of user, and now if I hover over the user type, you will see that it has the name string and age number, which was inferred from the user object. And now if I put here the user, and if I try to get the auto completion here, you will see that we are getting the name and age. So let's say I put age 28 and name is Jane Doe, and if I print to the console user2, you will see that we have a second object with the properties name and age. Here we have a handler function which is accepting a parameter called event type, which is of type string, and it is printing to the console handling event type. And here we are calling this handler function with a bunch of events: on click, key down, and on key up. We can also have handler, on, enter, and so on. The problem with this event type string is that we are not enforcing the event type here. Let's say that we always have the event type as on something, so on escape and so on. Right now we are not enforcing that, and we can call handler clicker, handler escape key, and so on. And it is not failing right now because we don't enforce the event type properly here. Because we want to enforce the prefix of on in front of all the strings, so we can replace this string with on and then string here. So now if we run this, you will see that clicker and escape key are failing because they don't have the prefix of on here. But if I add on in the beginning, so this is also passing now. We can also enforce specific keys here inside the template literal type. So I can replace this string with, let's say, click and key down. Now you see here the on click and on key down are passing, but the rest of the events are failing. And if I replace this again with the type string here, all these on events are passing. Here we have a class called person and we are passing it a parameter called name of type string here. Right now if we try to access the property outside here, let's say console.log johndoe.name, TypeScript will throw the error because the name is not a part of class person. If we want to access this outside, we have to define the property here called name type string, and we have to do here this dot name is equal to name, and the error goes away and we are able to access the name property outside. TypeScript has better way to do this property assignment, so we can remove the class property from here, and we can also remove this assignment from here, and all we have to do is just assign the access specifier to the property name here. So we can do public or private here, and the error will go away and we'll be able to access the name property outside. Let's say that we have a function called log which is accepting a variable called val with the type any. Now inside this function we can do anything with the val and TypeScript is not going to complain. So we can call the string methods, let's say val.to uppercase. We can do the numerical operation, so let's say val plus 20, and we can also call the unknown methods. So let's say val.something. Now if I call this method log with a number, let's say 5, even though the TypeScript is not complaining here, when we run this in the browser, JavaScript is going to break because to uppercase does not exist on the number type, and also something does not exist on the number type. TypeScript has another upper level type called unknown which can be used as a replacement for any. So I can put here unknown. The only thing you can do with the unknown type is assign it the value and put the equality checks. So let's say value equal to something or does not equal to something. For any other usage of the val type of unknown, you have to specify the type guard or the type first before you use it. So now in this case, if I have to perform the string operations on the val type unknown, I have to put the string type guard. So I will have to do if type of val is string, then call the to uppercase here. So now in this case the error goes away. And inside this type guard, I can perform all the string operations on the val. But outside this type guard, I can't still do anything. So here I have to wrap this val in the brackets and call as number for it to be considered as a number. So either specify the type guard or you can put as and then the type that you want to consider it with. And same for this one. Let's say that we had a type called sum which is having a method called something returning void, and now we can specify it here on the val with val as sum, and now we can call this something method onto the val. Here we have an ages type which is an object where the key is the name with the type string and the value for each of the keys is going to be number. And then we are creating an ages object with a bunch of different names with the value set to each of the person's age. And then we are printing to the console all the ages that we have here. There is a short form in TypeScript which can be used to represent this kind of types. So we can represent the same object type as type, ages type, record, and first parameter is going to be the key of the object. So in this case it is going to be string because we have names. And the second value is going to be the value of each of the keys, so number here. So now you can see that TypeScript is not complaining and we're able to get the same results as this type. We can also restrict the keys here. So right now we are being flexible with the names here. So it can be any string. So I can add, let's say Jenny Doe with 50 and TypeScript is still not complaining. Let's say that we only want 3 names. So I can put here type names type. So John Doe, Jane Doe and Baby Doe. Now I can use this names type instead of the string here, and now all these 3 properties are being allowed, but this property does not exist in the names type, so it is not being allowed. So I can add here Jenny Doe as well and the error goes away. We have a box type here with name and content. Content is of type string. Then we are using this box type for our string box variable, and we are assigning the name and content to this variable. Let's say that we need another box which is going to hold numbers here. So one way to do that is copy this box and create a new type called number box, where content is of type number here, and then we can use this number box type for our variable number box with the number box type, and we can put the content as number. Let's say that our application keeps growing and now we need another box which is going to hold booleans instead of numbers. So we can keep creating the copies of this box with the different types associated with the content. The issue with this approach is that we'll have a lot of box types here, and whenever we have to change one box, we have to go through all the box types and update them all. There are two ways to fix this issue of the duplicate types. One way would be to go with the unknown type, so we can remove this number box type from here and type the content as unknown, and we can use the same type box for the number box as well. The only issue with that would be that whenever we have to use some content, let's say that we have to console log string box dot content dot to uppercase, we have to put the type assertion because unknown cannot be used without the type assertion. So I have to do as string here, and same goes for the number box. Whenever we have to use this number from here, we have to put the type assertion as number. The better way to fix this would be to go with the generic object type, so we can pass it a parameter here. So box can expect a parameter of type t, and then we can use this type t for the unknown here. So I can put the t here. Now we are getting the error whenever we are using the box type. Generic type box requires one type argument. To fix this issue, we have to pass string here, and we also have to pass number here. And now we can get rid of our type assertion from here, and there's no error when we are using the to uppercase on our string box. And same for our number box. If I put here number box dot content, let's say multiply by 5, there is no error for that as well. We can also pass the default arguments to the generics. So I can get rid of this string from here, and I can make here equal to string. And now if we don't pass the argument, it is going to be considered as a string here.